Today we're going to talk about solving one-step and two-step equations. And at the top of your notes on page 1 in the packet, which is actually kind of page 2 on your packet, we have the title page. We've got a couple of practice problems. And when we look up here, when we're solving one-step equations, what we're trying to do is we're trying to use the inverse operation and get the variable by itself. And that might mean a little bit of foreign words there, so let me try again with that. But when we take a look at this, our first example is m plus 12 equals 10. What we need to do is we need to get the 12 to the other side of the equal sign. So we're going to use the inverse operation. We added 12, so the inverse operation is subtraction. We're going to subtract 12 from both sides, and we end up with m equals 10 minus 12. Now, if you're saying to yourself, I'm not very good with adding and subtracting, especially when there's a negative number, then we're going to go back to Desmos. And I may pull up Desmos in a couple of minutes, but I'm not ready to do that yet. If we look at example number 2, same kind of idea here, but we want to get, in this case, the letter G by itself. So we're going to add 9 here, and we're going to add 9 here. Negative 2 plus 9 is 7 equals G. So on the first example, we had to use subtracting on both sides because we were undoing the addition. On problem number 2, we had to add 9 to both sides because we were undoing the subtraction. As we look at example number 3 now, what's happening is we've got multiplication in this problem. Negative 7 times y. We want to undo the multiplication, and its inverse operation is to divide. So we're going to divide by negative 7 here. We're going to divide by negative 7 here. And when we do, that's going to give us our value of y, which negative divided by negative is a positive, and it's going to be 13, I believe. Let me think just briefly. Yes. And then the last part here in our one-step equations, we just need to do something to solve this. This problem says a divided by 9. We want to undo the division, and the inverse operation of dividing is multiplying. So we're going to multiply this side of the equation by 9, which means we need to multiply the other side of the equation by 9. 9 divided by 9 is 1. So we're left with 1a, and then negative 4 times 9 is negative 36. So in this next few problems, we have fractions in them. And once again, I'm really using inverse operations to do these. I know that I have them in one-step equations. With Desmos, we can do these in one-step equations, but we can also use on here reciprocals. reciprocal is reciprocal. In general, because we use Desmos, here's the way I look at it, but I'll do a couple problems one way and a couple problems the other. This problem number 5 is 2/3 times x. Well, the inverse operation of multiplying is dividing. You can divide by 2/3. You can divide by 2/3. 2/3 divided by 2/3 is 1x. And then we can flip over to Desmos and do 10 divided by 2/3. So divided by 2/3 gives us 15. Desmos does a lot for us. And again, we end up with 15. If we want to go the reciprocal route here, here's how the reciprocal route, or the reciprocal method works. So it's 4/9 times w. The reciprocal of 4/9, reciprocal means that we flip the fraction, and 4/9 then becomes 9/4. So we're going to multiply by 9/4, and then over here we're going to multiply by 9/4. We still need to use Desmos, but what happens on the left side of the equation is that 9 divided by 9 is 1, 4 divided by 4 is 1, and we're left with w. And then we can flip back over to Desmos and type in -8 times 9/4. -8 times 9 divided by 4, which gives us -18. So pick which method works best for you. Again, when we look at number 7, -6/5 times k, let's divide by -6/5. We're going to use the inverse operation. It's still one step. We're going to get k equals, and then we're going to go over to Desmos. Oh, darn it. And we get 12 divided by -6/5. Gives us -10. We can go back and fill that in. And finally, -1/2 times m. The nice thing about this one is that we can do this without using Desmos, maybe. But if we multiply by the reciprocal, then we're going to multiply this side by flipping the fraction. That's what the reciprocal is. So we're going to flip it. It's going to become -2/1. So over here, it's -2/1. And what we end up with then is -9 times -2, which is +18. So now we're into two-step equations. And one of the things that I realized that I did not scan in here into the smartboard file is to solve a two-step equation. It's at the top of your box there. It says undo the addition and subtraction, and then undo the multiplication and the division. So luckily, at least fingers crossed, this isn't the first time that you've seen these concepts. But what we want to do is we want to isolate the variable, which means get the variable by itself, and then we'll solve. So to get this variable, -4x is the term that has the variable in it, by itself, we're going to start by subtracting 9 from both sides. And when we subtract 9 from both sides, 13 minus 9 is 4, equals -4x. Again, do not hesitate to use Desmos. And then lastly, this is -4 times x. Now we're going to undo that multiplication by division, dividing both sides by -4, and we end up with x equals -1. Number 12, same idea. We want to get the 3x, the negative 3x, by itself so that we can solve this. Ultimately, we want to end up with x equals. So this time what we're going to have to do is we're going to have to move the 7. There's no sign in front of the 7. That means it's a positive. So to get this 7 to the other side, we're going to subtract 7. We're undoing the addition with subtraction, and we're left with negative 3x equals 27, which is, by the way, 34 minus 7. Well, now we want to undo the multiplication, negative 3 times x, so we're going to divide both sides by negative 3. And then lastly, we want to figure out what x equals, so it's going to be x equals negative 9. 27 divided by negative 3. Again, if you cannot do that in your head, please take the time to type it into Desmos or a calculator. Same idea on problems 13 and 14. When we take a look at 13 here, we're going to start by moving the 7. Since it's minus 7, we're going to add 7. We get x over 2 equals 16. This time what we have to do is we have to undo the division, and the inverse operation of dividing is multiply. So we're going to multiply by 2 here, we're going to multiply by 2 there, and when we do, we end up with x equals 32. 16 times 2. Number 11. Isolate the variable. Get the term with the variable by itself. This time it says plus 8, so we want to get that plus 8 over to the other side, so we're going to subtract 8. We're going to undo the addition with subtraction. When we do that, we get 3 equals x over negative 5. And once again, we want to undo the division here. And when we undo the division, we're going to multiply by negative 5 here, multiply by negative 5 here, and the negative 5's canceled out, and we end up with x equals negative 15. As we finish, let's move the 22. We want to get the variable by itself. Subtract 22. And we have 3/5 x equals 6. 28 minus 22. And again, because we're using Desmos, I think we're more likely just to do the inverse operation rather than multiply by the reciprocal. Both methods are good, but we can divide by 3/5. We can divide by 3/5. 3/5 cancel out, so we're going to type into Desmos x equals 6 divided by 3/5. 6 divided by 3/5, and we end up with 10. Same idea to finish up here. We're going to isolate the variable. Since it's plus 1, we're going to subtract 1. We get negative 1/3 x equals negative 8. And again, because we have Desmos, it's just as easy to type that in. It's a little bit easier if we use the reciprocal, but I think, and I'm not sure yet because I don't know you super well, and I think that most likely we can simply divide by negative 1/3 because that's undoing the multiplication, And then what we're going to end up with is we're going to end up with negative 8 divided by negative 1/3. Negative 8 divided by negative 1/3. And we get 24.